Hey you guys, welcome back. Let's do the rest of the study guide. So let's look at number 9. This says, please complete the equation using the property. So this first one says, complete this with the commutative property. And remember, commutative is the property where we change the order. Commutative starts with a C and an O. I always think of it as change the order. Change the order of the numbers. So 13 plus 8, if all I'm doing is changing the order of those numbers, I'm going to do 8 plus 13. Because we can put numbers in any order and still get the same answer when we add them. 13 plus 8 is 21. 8 plus 13, also 21. We can add in any order, and that's because of this property. Let's look at the next one. 4 times 7 times 9. So the only thing that's changing is the order. So we can put it in 7 times 9 times 4, as long as the order is different. All right. This property tells us that whenever we add numbers or multiply numbers, we can put them in any order and get the same exact answer. Let's look at the next one, the inverse property. Now, we've been talking about the first one since like the first week of school for a long time now. Whenever we use the additive inverse, I add two opposite numbers, and I always get 0. Negative 9 plus 9 is 0. Let's look at the next one, 1/4 times 4. Now, this word is really important. You guys are going to hear it a lot in all your math classes you ever take, the reciprocal. Whenever we talk about the reciprocal of a number or a fraction, we're just flipping that fraction. So 1/4, its reciprocal is 4 over 1. All right, we just put the top number on the bottom and the bottom number on the top. Now, I'm not going to write 4 over 1 as a fraction because that's just a whole number. It's just 4. So 1/4 times 4. Whenever we multiply reciprocals, we always get an answer of 1. Because if I actually multiplied this out, change that to multiplication, a large multiplication dot. I had 1 times 4, that gives me 4. 4 times 1, that gives me 4. And that simplifies down to 1. We always get an answer of 1. All right. Let's look at the next one, the distributive property. If I actually go and distribute that 2 to everything inside the parentheses, I get 2 times 7x, that's 14x. 2 times 5, that's 10. And I'll just keep the subtraction sign I have right there. Let's look at the next one. I have this negative 3 I need to distribute. I'll distribute it out. Negative 3 times 2y, that gives me negative 6y. Negative 3 times 6, that gives me, negative 18. And then you have this minus inside right there. Now, you could write this one of two ways. Okay, you could leave it just like that, and that's fine. But it's really important that we recognize that this is the same as negative 6y plus 18. Because I could have gone in here and changed that subtraction to addition and the sign of the following number. And that's always a really good idea so you don't get the signs mixed up. So now, negative 3 times 2y is negative 6y. Negative 3 times negative 6 is positive 18. And I'm left with that plus sign in the middle. Okay? It's really important that we can see that these are equivalent expressions. Let's look at this one. Which expression is not equivalent to 7y minus 4? So it looks like these are all asking me to combine like terms and simplify these expressions. If I go and combine like terms, I got to go and do all of them so I can see which one is not equivalent. So one of these is not going to give me 7y minus 4. Let's look at this one. Negative 5y and 12y, those are like terms. I'll combine them and get 7y. 8 minus 12, that's really like plus negative 12. That gives me 4. Hey, that's the same thing. Perfect. So that one is not it. B, I'm going to go combine like terms. And again, it's always a great idea to change subtraction to addition and the sign of the following number. All right, it's easier to keep up with our signs that way. 4y and negative 3y, that gives me negative 1y. I'm not going to write that instead. I'm just going to write negative y. We never have to write the 1 if that's the coefficient. 9 plus 5, that gives me 14. Oh, that doesn't look like that works. Let me go double check with the other ones, okay? Negative 8y and 14y, that gives me 6y. Oh, but there's one over here. 6y plus 1y, that gives me 7y. Negative 5, or plus negative, that's a negative 5 right there. Plus 1, that gives me negative 4. Minus 4, that's great. That one checks. Look at the last one. Negative 3y, we'll change that to plus a negative and plus a negative. So I'm left with negative 3y plus 10y. That gives me 7y. Negative 5 plus 9, that gives me 4. Plus negative 8, that gives me negative 4. Hey, so that one checks too. So it looks like the one that's not equivalent is this one right here, letter B. Let's look at this one. Which of the following statements about properties are true? There are 3 correct options. Let's see. The inverse property says that multiplying a number by its reciprocal equals 0. It does not equal 0. Whenever we multiply a number by its reciprocal, like 3/8 times 8 over 3, that's the reciprocal of that. I get 24 over 24, which just breaks down to 1. I was getting an answer of 1, not 0. If this said adding a number and its opposite, add number plus its opposite, that would give me 0, but not with multiplying. Let's look at the next one. When using I'm going to mark that out because that's not true. When using the associative property, the grouping of the numbers changes. Hey, that is true. We did that up above. When we change the grouping, where the parentheses are, that is the associative property. Look at this one. When using the commutative property, the operation of the numbers changes. The operation, remember, operation is like addition, subtraction, multiplication, and division. The operations never change. That is not true. When using the commutative property, the operation doesn't change, the order changes. That's what changes, the order of the numbers. Let's look at the next one. The inverse property says that adding two opposite numbers equals 0. Oh, hey, that's actually exactly right, because we've learned that since the first week of school. The inverse property says that adding two opposite numbers, so the additive inverse is like 3 plus -3, and that does give me 0. That's right. Look at the next one. When using the associative property, the operation of the numbers changes. Again, the operation never changes. We're not talking about the operation. The associative property changes the grouping. So that one's not it. When using the commutative property, the order of the numbers changes. That is true. That's the word we're looking for. The commutative property changes the order of the numbers. So that is true. All right, let me give that an erase so I can scroll down. Let's look at number 12 right here. Please write the reciprocal of these numbers. So looking over here, I'm going to go write the reciprocal. Now, whenever we talk about the reciprocal, that's just where we flip the fraction, all right? So the reciprocal of 1/4, I'm going to put the bottom number on the top and the top number on the bottom. So now this reciprocal is 4 over 1. But remember, any number over 1 is just a whole number. So this is really just 4. Look at this one, the reciprocal of 5. It looks like there's no denominator here, but remember, any whole number has a denominator of 1. So I would put the denominator up the top, the numerator down below in the bottom. So now I have 1 over 5. That's the reciprocal. Look at this one, -3 over 8. I'm going to put the numerator down below and this denominator up at the top. So now I have 8 over 3. Now, two ways to write this. I always leave the negative in the numerator. You could also write instead 8 over -3. These are equal fractions. They're equivalent. Whichever way you did is just fine, all right? As long as you only have one negative sign in there. If you have two, that's wrong. Two negative signs is a problem. But as long as you have one, you can put it in the numerator or the denominator. And the last one, -13. Again, every whole number is over 1. So I'm going to put the top number in the bottom and the bottom number up here on the top. So I have 1 over 13. And I always keep the negative in the numerator. All right? But you can also write 1 over -13. Either way, just fine. Let's look at this one. Mr. Gann stayed at a hotel for n number of nights. The hotel costs $50 per night plus a $20 one-time fee for his dog. Which expression represents the total cost of the hotel? Now, n number of nights, that's really important. It's underlined because that's critical. That's super important. We're trying to figure out where the variable n is going to go in our equation. Is it going to match up and go over here with the Is it going to go with the 50, or is the n going to go over here with the 20? It says the number of nights, so the n has to go with whatever number is talking about the number of nights. $50 per night or a $20 one-time fee for his dog? Well, it's going to go over here for the nightly cost. So I'm looking for 50n because those go together. Plus a $20 one-time fee for his dog plus 20. Let's see what matches with that. 50n plus 20. Hey, it's letter D. Perfect. Let's look at the next one. Now we have some equations we're going to get into. So whenever we do equations, essentially all we're doing is the inverse operation over and over and over again. Because the whole entire goal of doing these equations is trying to figure out what x equals. Or in some of these cases, an a or a y. Whatever the variable is, we want to figure out what that variable equals in the equation. So let's look at the first one, 3x equals 21. You have to remember, whatever operation is going on with the variable, we have to undo that and get rid of it by doing the inverse operation. So remember, this 3 and the x is really being multiplied. We just don't write the multiplication symbol in there. To get rid of multiplying by 3 with that x, I'm going to do the opposite and divide by 3. I always set up a little division bar and then put 3 down below. That reduces down to 1 because 3 divided by 3 is just 1, which is what I want. I want a 1 in front of the x. I want that coefficient to be 1. Do the same thing over here, divide by 3. So now I'm left with x equals 21 divided by 3. That just gives me 7. And I'm going to show you guys this because I really want to make sure you are doing this. Let me grab a calculator right here. Now, whenever you see these problems, you can always go and check your work. These are the calculators you guys use, all right? If I know x is equal to 7, I want to go and use substitution and replace that x with a 7. And if my answer is right, it should give me the answer to the other side of the equation. So let's go plug it in. 3 times 7 is equal to 21. Let's see if that's true. 3 times 7, perfect, it is. A lot of you guys know that 3 times 7 is 21, but I just want to show you the importance of the calculator, all right? You can check your work. So I know I did it correctly. Let's look at the next one, x minus 9 equals 6. So I'm going to do the inverse operation to get rid of whatever is around the x. Right now, there's a minus 9, a subtracting 9. To get rid of subtracting 9, I'm going to add 9. This now becomes negative 9 plus 9, which just cancels out, and I'm left with a 0. I'll do the same thing over here. So now I have x is equal to 6 plus 9, that's 15. And again, if you wanted to go and double check your work, you could use substitution and put that 15 in for x. So 15 minus 9, does that equal 6? Yes, it does. So I did it correctly. Let's look at this one over here. X divided by 2 equals negative 6. Don't get intimidated by that division bar. That's all it's telling me. So instead of it being adding something to x or dividing or multiplying something with x, now I'm just dividing it. If I want to undo that division, I'm going to do the opposite operation. So instead of dividing by 2, I'm going to multiply by 2. And now this is 2x over 2. Those 2's reduce down to leave me a 1, which is exactly what I want. I'll do the same thing over here, multiply by 2. I'm left with x equals negative 6 times 2. That's negative 12. If you wanted to go and double check your work, use substitution and use that negative 12 in for x. Negative 12 over, that was a 2. Yep. Negative 12 divided by 2 equals negative 6. It sure does, so I know I did it correctly. Let's look down here. 5y plus 3 equals negative 12. Now, whenever we have an equation like this is a two-step equation. I always have to eliminate the constant first, the number that's all by itself without a variable. And I'm not talking about this negative 12 over here. That is technically a constant because it's by itself. I'm talking about the constant on the side with the variable. This 3 is on the side with the variable, so I'm going to get rid of that constant. To get rid of plus 3, I'm going to do the opposite. I'm going to subtract 3. I'm left with 0, which is exactly what I want. I'm going to subtract 3 over here. 5y is what I'm left with, is equal to negative 12 minus 3. Now, this is where I really want you to maybe use the calculator or at least double check your thinking. Kids always do negative 12 minus 3 and they think 9. That is not what we're doing here. When I put negative 12 minus 3 in the calculator, I get negative 15, which is exactly what I should get. Because if you were going to write this out, you'd see negative 12 minus 3. That's like plus negative 3, which gives me negative 15. All right? So double check your work and be careful. So now I have 5y is equal to negative 15. I have to get rid of this 5 somehow. It's currently being multiplied by the y. To get rid of multiplying by 5, I'm going to divide by 5. That's the inverse operation. I'm left with a 1. I'll divide by 5 over here. So y is equal to negative 15 divided by 5. Again, if you're not sure about the signs, use your calculator. Negative 15 divided by 5 gives me negative 3. It shows me in the calculator, okay? All right. You guys, thank you for sticking around for the whole video. Check out the next part of the study guide in the next video.